Okay, we are going to do an instructional video on writing functions from real-world problems. Okay, so the first one we're going to do is Jill opened a bank account with $100 she received for her 14th birthday. To help her save a card, Jill decides to deposit $10 of her allowance each week. Okay, so her account balance depends on number of weeks. And I say that because if she adds $10 for the first week, it's $10. If it's 2 weeks, it's $20. So it keeps increasing as she keeps on adding more money. So the dependent variable, what she starts with, is the account balance. And the independent variable, which changes, is the number of weeks. Okay, so now we're going to write a function. Balance for B, W for weeks, equals 100 plus 10 times weeks. Now, we want to know how much money she has after 23 weeks. So the weeks becomes 23. We just substitute it into the equation. And so wherever the W was, we put in 23. So B times 23 equals 100 plus 10 times 230. 10 times 23 is 230. And so the total would be 330. So now we have the numerical answer. In weeks, we're going to turn around the statement. How much money will Jill have after 23 weeks? Jill will have $330. Jill will have $330 after 23 weeks. So now we have the solution numerically and in written language, okay? So now we have the next one. If Jill wants to buy a car that requires $1,000 down payment, how many weeks will she need to save? So we know we need a total of 1,000. We know that she started with $100 as above. We know she puts in $10 a week, but we don't know how much she puts in. So now we're going to solve it. So we're going to get rid of the constant on both sides, so we subtract 100. So 900 equals 10W. So here it's 10 times W. So we're going to divide by 10 on both sides. So 90 equals W. So it's going to take her 90 weeks. So it will take Jill 90 weeks to save $1,000. Okay, so now we have it in numerical and we have it in written language. Now I want you to take and see, there's 2 more problems as you flip it over, okay? And we will go over that in a few minutes. I would like you to try and solve these on your own, and I'll be back in a few. Okay.